Hey guys, in today's video we'll be covering Unit 1.7 of the Math AA SL and HL course, which is further exponents and logarithms. And this unit or this subunit is essentially building upon what we learned in Unit 1.5. So I'd recommend watching that video before going here. But anyways, rational exponents are basically exponents exponents that are fractions. So like x to the power of a half. So rational exponents are just when the exponent is a fraction basically, or a decimal. And how do we work with rational exponents? Now, the simplest way of showing or illustrating this is if we just square this x to the power of a half here. We just square the whole thing. And using our exponent laws, we know that this is basically x to the power of a half multiplied by x to the power of a half, right? And using our logarithm rules, our exponent rule, sorry, again, this would be x to the power of a half plus a half, right? You know what, let me actually put the logarithm rules or the exponent laws over here on the side. This is again unit 1.5, and then this would be x. So what we basically have is that x to the power of a half times x to the power of a half equals x, right? Now, what we just said here is that a number multiplied by itself gives a number. And where else have we seen this? Well, we can also say that root x multiplied by root x equals x, right? So if x was 64, then root x would be 8, root x would be 8. 8 times 8 equals 64, right? So here we have a similarity where these are basically the same thing, right? We can say that x to the power of a half equals root x. And we can actually generalize or put this in more general terms. So what we can say is that x to the power of 1 over n equals the nth root of x. Okay, so if this here was a 3, this would be 3. If this was 10, this would be 10. It's that simple. So let's take it a step further. What if we had like x to the power of 3 over 2, right? How do you do this now? Now, again, using our exponent laws, exponent laws, especially the fifth one here, we can basically write this as x cubed to the power of a half, right? Because then it would be 3 times a half, which would be 3 over 2. And now we have it in this form. We have it in the form of x to the power of a fraction. So what we can do is we can write it again like this. But this x now is to the power of 3. So this here becomes to the power of 3. So again, to write it in more general terms, we have x to the power of m over n is basically written as the nth root of x to the power of m. And again, with these exponents, all of these laws here apply. All of these laws apply to rational exponents, right? So rational exponents at the end of the day is just another way of writing roots. And next we move on to logarithm laws. And similar to how we had exponent laws, right? There's also laws or rules for logarithms to make it easier to work with them. So there's three main rules which we're gonna discuss now. And the first one is, let's say we had log base 2 of 8 plus log base 2 of 4, right? How can we simplify this? Now let's first work it out using these conversions here. So log base 2 of 8 is basically 2 to the power of what gives us 8? 2 to the power of 3 gives us 8, so this here is 3. Plus log base 2 of 4 is 2, and this is basically 3 plus 2 is 5. So this here is 5. Now, since these both have the same base, let's say we'll do now 2 to the power of the answer we got, 2 to the power of 5. And this here gives us 32, right? So now we have 2 to the power of 5 is 32. And if we rewrite this as a logarithm, what we will have is log base 2 of 32 equals 5. So what we have now is log base 2 of 8 plus log base 2 of 4 is 5, and log base 2 of 32 is 5. So they both equal the same thing. And what similarity do we see between them? Well, this 32 here is basically 8 times 4, right? And this brings us to our first law, which is basically log base x of a plus log base x of b is equal to log base x of a times b. Okay, this is our first logarithm rule. And the first very, very important thing here is that the base, this x here, has to be the same. Okay, so if this was a 2 and this was a 3, we can't apply this law. This base has to be the same. And we'll get to discussing how we can change the bases a bit later on in the video. But for now, let's just take this rule here and we'll keep it here. And let's move on to our second law, right? So let's just get rid of this. Let's move on to the second law. And this time we'll say we have log base 2 of 16 minus this time log base 2 of 4. And like building upon the last law, you can probably guess what's going to happen here, but let's just go through it. So log base 2 of 16 would be 4, right? 2 to the power of 4 is 16. Minus log base 2 of 4 is 2, because 2 to the power of 2 is 4. And this here gives us 2. So this here is 2. And again, our base is 2 again, so we're going to put 2 as the base. And our answer is 2, so 2 to the power of 2. And this gives us 4. So let's write this here as a logarithm again. So if you do that, we would have log base 2 of 4 is 2. So now we have this here equals 2, and this here equals 2. And what similarity is there between them? Well, this 4 here is basically 16 divided by 4. So we're adding them here, multiplied them, subtracting them, essentially just divides. It does the opposite. So our second law is that log base x of a minus log base x of b. Again, very important, the base has to be the same. This equals log base x of a over b, or a divided by b, right? So pretty similar to the previous law, but instead of adding, now we're subtracting, and instead of multiplying, now we're dividing. Let's put this here again. So this is our second law. And now we move on to the third and final law. And these laws are actually pretty simple, and they are given in the data booklet, so you don't have to memorize them. You just have to know when to apply them, basically. But anyways, our third law is, let's say we had log base 3 of 9 to the power of 3. Okay, how can we write this in a simpler way? Well, first of all, what we know here is that log base 3, 9 cubed, or 9 to the power of 3, is basically 9 times 9 times 9, right? Because 9 to the power of 3 means 9 multiplied by itself 3 times. And what we know here is that 9 times 9 times 9, using our first law, something times something, is basically the logarithm of something plus the logarithm of something. So let's rewrite this here. Let's rewrite this using the first rule as log base 3 of 9 plus log base 3 of 9. I don't know what these 3's are. Let me just fix them real quick. Log base 3 of 9 plus log base 3 of 9, right? So log base 3 of 9 times 9 times 9 is basically this. And now we have log base 3 of 9 added by itself 3 times. So basically have 3 log base 3 of 9's, right? 3 times log base 3 of 9. And what we'll notice is that this here, basically what happened is that this 3 just moved to the front, right? And we can actually solve this because we know that log base 3 of 9 is 2, so that's 3 times 2, which should give us 6. So this here is 6, right? And to put our last and final law in words, basically we can say that log base x of a to the power of b is basically b multiplied by log base x of a, right? This is our third and final law. Again, all of 3 of these laws are given in the data booklet, so you do not have to memorize them. You just need to know when to apply them, and we'll get to that now. But yeah, these are your 3 basic logarithm laws. So next we move on to properties of logs. And these are not exactly rules, but they're stuff that like you should see them and think immediately, oh, I can just simplify this to this. And you'll see what I mean right now. So our first property is, let's say we had log of 1, right? So log base 10 of 1. What's the answer here? So we'll say this equals x. Now, if we rewrite this as an exponent, this is basically 8 or 10 to the power of what gives us 1, right? Now, from exponent laws, we know that anything to the power of 0 gives 1. So x here has to be 0. So our first property, or yeah, property, not really a law, more like a property, but basically, whenever this number here is a 1, no matter what the base can be anything, but if this here is a 1, your answer is 0, right? Because then this to the power of this gives us 1. So whenever this is 1, answer is 0, no matter what the base is. That's our first property. Pretty nice and simple. You can just see it and immediately think, oh, this is 0, right? No, not much thinking required. Now, our second property is, let's say we had log base 3 of 1 over 9, right? How do we do this? Now, first things first, we know that 1 over 9 is basically 9 to the power of minus 1, right? Using, again, our exponent laws that we discussed in 1.5. Anyways, using our last logarithm law, we know that if this was 1 minus 1, just move it to the front. Just move this to the front. So what we have now is minus log base 3 of 9, right? And you know that log base 3 of 9 is 2, so the answer here is minus 2. So very simple. Again, another property is that log base x of 1 over a number is basically minus log base x of just the normal number. Yeah. And again, we know this that like 3 to the power of minus 2 is basically 1 over 3 squared, which is 1 over 9, right? So we know that it is a negative answer. Anyways, that's our second property. And moving on to the third one, let's say we had this time, okay, we had x, so any number x to the power of log base x. You know what, let's use an actual number. So let's say 3 to the power of log base 3 of 4, right? Or let's not do 4, let's do 9. Let's make it a nice number. How do we do this? Now, the first thing we know is that log base 3 of 9 is 2, right? So what we can put this as is 3 to the power of 2, right? We just put this as 2. Now, let's take this log base 3 of 9 2 here. It's in this form. Let's write it in this form. So what we'll have is that 3 to the power of 2 equals 9, right? So here we have 3 to the power of 2, and we know that this equals 9. So if this equals this, and this equals this, this means that this equals this. So what we basically did was just ignored all that, and this is basically the answer, right? So to put it in more general terms, log base x, or sorry, no, x to the power of log base x of a, right, is just a. So if a number to the power of log base the same number of a number, the answer is that number, right? A bit weird, but yeah. And again, if this was e and this was e, so if this was e, this was ln basically, because we know that log base e is ln. So if this was e, this was ln, the same thing would apply. So e ln of a is a. And yeah, these three properties, if you're just doing an equation and you see log 1, you just immediately know the answer is 0. It's just something you need to know straight away. So next we move on to our change of base formula. And if you remember before, we said that in order to apply the logarithm laws, the base has to always be the same. So if the base is not the same, what we can do is this change of base formula over here. So the general formula is that log base a of b is basically ln of b, or not ln, sorry, log base x of b divided by log base x of a. And what this means is that this x here can be any number you want. You can choose any base you want, and I'll get to why in a second. But yeah, so log base this just log of this over log of this. All right, and I'll do the proof now. You don't need to know the proof, but it's pretty nice to know. And yeah, I'll explain why it can be any base. But anyways, let's say the log a of b is c, right? So if we rewrite it, we'll have a to the power of c gives us b, right? Let's actually split this out, gives us b. Now what we can do is we can logarithm both sides of the equation. So you know how sometimes you're solving equations, you multiply both sides by 2, you square both sides, you divide both sides by 10, whatever. You can basically just also logarithm both sides, right? It doesn't change the equation that much. Or it doesn't, they're both still equal to each other. So again, when we do this step, we can literally choose whatever base we want. And I'd recommend always using ln, basically just because it's the fastest one to write, and the easiest one to write. There's not much to it. But yeah, anyways, using our third law of logarithms, we know that this c here moves to the front. So now we have c times log base a equals, or not log, here's ln of a equals ln of b. And what we can do next is we can divide both sides by ln of a, and hence we have c equals ln of b over ln of a, right? That's here. So log, this would be e here, this would be ln of b over ln of a. So we just proved the change of base formula right now. And why exactly is this formula so useful, you may ask? Now, let's say we have log base 3 of 6 plus log base 9 of 4, right? Now, we know that from our logarithm laws that we can basically just multiply these together, right? However, we can't do that right now because these are not the same base. We need to make these either both 3 or both 9. And how do we do this? Well, we just use this change of base formula, and I'll show you how now. Anyways, what I'd recommend is always taking the bigger one and making it a smaller base. And I'll show you why right now. So if we just work with this, what we have is log base 9 of 4 equals, using our change of base, ln of 4 over ln of 9, right? Now, what we also know, or what we can do, is we can rewrite this ln of 9 as ln of 3 squared, right? Because we know that 3 squared is 9. And why do I put 3? Because we want to make the base into 3. That's why I change this into 3, right? So whatever you want to change the base into is whatever you change this number here into. Anyways, using our laws of logarithms again, this would be ln of 4 over 2 multiplied by ln of 3. So we just move this 2 here to the front, right? And now we can just separate them since they're being multiplied by each other. So it becomes a half times ln of 4 over ln of 3, right? And now we have it in this form again, right? We have the same form we started in, but now the base is different. Now the base is 3. So if you write this as a normal logarithm, what we have is 1 half times log base 3 of 4, right? 1 half log base 3 of 4. And again, what we know from logarithm laws is that this kind of just moves to the front. So this becomes log base 3 of root 4, or basically log base 3 of 2, right? So I'll just move this here for now, solve it here. What we have now is, solve it here, log base 3 of 6 plus log base 3 of 2, right? We change this log base 9 of 4 here to a log base 3 of 2. And now since there's the same base, we can just multiply normally, and we have log base 3 of 12. And you would need a calculator for this, but yeah, it's whatever. We did get it to the same logarithm, right? And the reason why I said to change this to the smaller number is because it's really easy to just put 3 squared here To change it to a 9, you would have to put it as ln of root 9, right? To change the root 9 into a 3. So that's why I recommend taking the bigger number and changing it down to its root. But yeah, this is our change of base formula, and it's really useful when solving logarithmic equations. So we'll finish off this video with a past paper question where we're just asked to find the values of m and n, right? And whenever I'm solving logarithm questions, the first thing I like to do is put everything in the same base. So we want to change this base 9 to a base 3, and we want to put this m, somehow we want to change it to a base 3 logarithm. And how exactly are we going to do that? Well, it's actually pretty simple. I'll go over it now. Anyways, so first thing we have our m as normal. And what we want to do with this m is we want to multiply it by log base 3 of 3. And why log base 3 of 3? Well, log base 3 is what we're looking for, right? And log base 3 of 3 is 1, because 3 to the power of what gives you 3? 3 to the power of 1 gives you 3. So this here is basically just m times 1, meaning that nothing really changed, right? So this here is what we do. And next we subtract and log base 3 of 2. We don't really change anything here. What we do change is this last log, because we want to change the base. So we start applying our change of base formula, right? ln of 6 over ln of 9. So this is our first step. Second step is using our third law of logarithms. We know that we can move this n up here and move this n up here. Sorry, m and n. So what we have now is log base 3 of 3 to the power of m minus log base 3 of 2 to the power of n gives us 10 multiplied by ln of 6 over ln of 3 squared, right? We kind of just went over how to change this to a 3 in the last section. We'll go over it again just in case. Anyways, using our second law of logarithms, we know that when it's subtracting, it's basically just this divided by this, right? So what we have now is log base 3 of 3 to the power of m divided by 3 to the power of n, or not 3, 2 to the power of n. And this here gives us 10 multiplied by ln of 6 over 2 ln of 3, right? We just use our third law to bring this 2 down here. And what we can actually do is we can move the 2 to just divide it by the 10 straight away, right? This 10 actually, oh, whatever. So 10 over 2 times ln of 6 over ln of 3. And so next step, this side just stays the same for now, right? Over 2 to the n. Now, first things first, 10 over 2 is just 5. And now we have it as ln of 6 over ln of 3. We have the base is 3, which is what we wanted. So let's write it as a normal logarithm. So log base 3, and now the top number is 6, right? And what we do next is, again, this side stays the same. So 3m over 2n. And this here equals log base 3 of 6 to the power of 5, right? We again, since it's multiplying, we just move this up here. And what we can do next is, so log base 3 of a number equals log base 3 of a number, right? So basically what we know is that this number and this number are the same. Since the outside is the same, the inside has to be the same. So what you can do is you can just ignore the logs for now. You can just cross them out. And what we have is 3 to the power of n over 2 to the power of n equals 6 to the power of 5, right? So where do we go on from here? Now, what we want to do is we want to have all the bases the same, right? So we want to change this 6 into 3's and 2's somehow. So how do we change a 6 into a 3's and 2's? Well, what we can do is we can change the 6 into 3 multiplied by 2, right? And this is to the power of 5. And I'll continue up here. So let's actually put this in pink, 3 times 2. So what we have is 3 to the power of m. And what we know is that 2 to the 1 over 2 to the power of n is basically 2 to the power of minus n, right? So this here is multiplied by 2 to the power of minus n. we can bring this up here, right? And this equals to 3 to the power of 5 multiplied by 2 to the power of 5. So what we see now is 3 to the power of m multiplied by 2 to the power minus n is 3 to the 5 multiplied by 2 to the 5. So immediately we see m is 5 minus n is 5. So we immediately see that m equals 5 and minus n equals 5, right? And this minus n equals 5, we change it to n equals minus 5. So let's actually put this in white. So what we have in the end is m equals 5, n equals minus 5. And this is it's actually a pretty nice question when you think about it. And one thing I want to say is that let's say this m here was a 2, right? Let's say this wasn't an m, let's say this was a 2. How do we do this if this was a 2? Well, the way you'd write this as ln is the same thing. You just multiply 2 by log base 3 of 3, right? You'd still do the same thing even if you had the number. But yeah, this is how you'd solve this kind of question. And these questions are pretty common. Logarithms are a pretty common thing. So it's nice to be familiar with the laws and especially with the change of base formula.